Hello everyone, this is PG Piazzala, paper number 06, Radiation Biophysics. I am going to talk about digital radiography. I am Dr. Ajay Kumar Srivastava from University College of Medical Sciences and Guru Tegh Bahadur Hospital. Digital radiography is defined as a method of radiography and image constructed from numerical data, and information is represented in the form of discrete unit, that is the number, and involve the use of computer. It uses matrix to represent the image. Matrix is equal to the rows into the columns. The smallest unit of matrix is called pixel. Pixel is the stored individual grayscale of an image. Objective of this lecture is to describe the basic principles involved in digital radiography, describe the structure of image receptor in computed radiography, describe the structure of image receptor in digital radiography, and I'll also discuss about use of PACS, picture archiving and communication system, in radiology. Digital radiography is of two types. One is known as computed radiography, another one is digital radiography. Of course, both of them are digital only. Digital radiography is divided into two types: direct digital radiography, indirect digital radiography. Now coming to the computed radiography, it is a computer based radiography in which digital way of doing the general radiography with conventional X-ray machine. It refers to the projection of X-ray image using photostimulable phosphor plate, PSP plate. CR image acquisition, as you can see in the figure, has been described. The patient is standing on the, and PSP is records the latent image formation, and then this latent image formation is read out by using digital reader, image reader. The principle of photostimulable luminescence is that photoluminescence is the property of some material which emits light promptly in the way that scintillation does following X-ray exposure. However, they also emit light sometime later when exposed to a different light source, and such a process is called photostimulable phosphor. This is the diagram of photostimulable phosphor. Now, component of digital radiography, we will discuss first of all the image receptor, that is the imaging plate, then ID tablet, which is image reader, ID tablet, CR readout, processing server, and workstation of a computed radiography. The imaging plate, this acts as an image receptor, also known as photostimulable phosphor screen. This PSP plate is housed in a cassette having active layer containing barium fluorohalide doped with divalent europium. Mind it, this doping causes defects in the crystal called F centers. Now coming to the construction of PSP plate, photostimulable phosphor, there are multiple layers in the PSP phosphor plate. One is called overcoat or protective layer, phosphor layer. Second, light emitting layer, conducting layer, supporting layer, and light shielding layer. A typical CR plate is shown in figure. You can see all these layers. The heart of this one is a barium fluorohalide activating with europium, activated with europium, divalent europium. So, how does CR work? First of all, a latent image formation takes place. Whenever phosphor is used to radiography, they are mixture of barium fluorohalide activated with a small quantity of europium as an activator. This doping creates a defect in the barium fluorohalide crystal, which allows the electron to be trapped efficiently. The following steps are involved. First of all, the exposure steps are explained. The steps are: during unexposed stage of IP plate, the electron in the lower energy state, that is there on the valence band. When X-ray falls on the imaging plate, during exposure photoelectric interaction takes place and the absorbed energy excites the electrons associated with europium. So, divalent europium converted to the trivalent europium, and electron is excited to the high energy state, to the conduction band. When it comes back to the valence band, it is trapped in the trapped energy level. It gets trapped in the metastable state, and they remain trapped for a minutes or hours only when a small amount of light is emitted. So, billions of electrons are trapped in the AF centers or trapped energy level. As you can see here in this figure, the electron has been excited from valence band to conduction band, and after exposure in fact, now it remained trapped. Now, how these trapped electrons are converted into a latent, that means converting latent image into digital image? It has the mechanical features, optical features and computer control with those features as in the scanner IP as shown in the figure. Here what happens is that the excited electrons which are trapped in the form of latent image, these trapped electrons are given additional energy by scanning with the laser beam. The laser beam scans, when it scans the plate after exposure, the excited electrons goes up to the conduction band, and when they come back to the valence band, they produce light, and this light is detected by photomultiplier tube. Now, there are two types of light. One is the light emitted by the laser beam, another one is the visible light produced by scanning the laser beam. So, there is a filter which filters out the laser beam and allows the visible light emitted by the exciting phosphor plate. So, light emitted by exciting the phosphor plate is recorded by the photomultiplier tube in the form of visible image. So, that means the less electrical signal is converted into some form of digital signal, and this is how the digital signal is projected, is converted back into the grayscale image. As I told you, the conversion of latent image into visible image, the cassette is put into the reader and IP is removed mechanically from the cassette. Then imaging plate is scanned by a laser beam. I told you about 750 nanometer of wavelength, and a deflecting device such as rotating polygons or oscillating mirror deflects the laser beam back and forth across the imaging plate. The laser scans imaging plate line by line in a raster fashion. During scanning, some energy absorbed at AF centers, and thus electrons get this energy and transferred to the electrons. These energy, the fraction of electron gain enough energy to reach to the conduction band and becomes mobile and draws back to the ground state to the valence band, emit light. that means europium, trivalent europium converted back to divalent europium. Emission of blue light is radiated in the form of light which is detected by the photomultiplier tube. Therefore, the photodetectors are also used, like PMT or CCD arrays are used. Fibroscopic light fiber plate is placed before the photodetector, which transmits blue light, attenuates the red light emitted by the laser beam. Photodetectors converts light into electrical signal whose output is in analog form, as you can see here in this figure. The time varying analog signal is processed for amplitude, scale and compressed. Sampling and quantization takes place. Further imaging is taking place so that it can be reused for another exposure without any ghosting. So this is therefore the plate is exposed to very intense light of sodium light, which removes all the metastable electrons to their ground state and thus emptying the most of the F center's electron, and therefore now the cassette is ready for use for another exposure. Otherwise, if this is not scanned, then some remnant image will be lying, which might produce an artifact known as a ghost image artifacts. So remnant image might be visible on the image. Another precaution is that the exposed place must be read out as soon as possible, because otherwise some fading will take place. Some of the excited electrons might get back to the valence band. Now, advantage of CR plate. It is extremely wide latitude, no need of any dark room. It uses existing X-ray equipments, conventional X-ray units, and can support multiple X-ray rooms. So high throughput and very less repeat exposure. Post processing, zooming, image inversion is possible. Time consuming. Simultaneous availability of image at different places. Whether the disadvantage of CR is due to phosphorescence, fading of image in IP plate, in imaging plate might take place over a time. This is why I told you that plate should be read out as quickly as possible. Once imaging plate is cracked and damaged, it has to be replaced, which is costly. Spatial resolution is less compared to the conventional film screen radiography. If image processing reader having one mechanical and optical part falls, then results in a whole system disruption. Patient dose required is same, more or less same as the film screen radiography. So CR does not add up any additional dose, because it is used with the same X-ray equipments, with the same almost same exposure factors, same kVp and MAS. So we have seen that this CR plate, CR computed radiography is very widely used nowadays. Instead of darkroom film screen radiography has completely, this CR computed radiography has completely replaced conventional film screen darkroom radiography. And now coming to the another type of radiography called digital radiography. This digital radiography, it uses the class of detectors in which digitization of X-ray signal takes place with on detector itself. So this is a part of digital detector system, receptors. Detectors are manufactures that combines the process of image capture and image read out there, then and there itself. There are two type of DR. One is called direct conversion, like photoconductor selenium plate is used, another with the flat panel detector, Another one is the indirect conversion, wherein scintillation with TFT and scintillation CCD is used. The basic principle of formation of DR image is shown in this figure. Basically, when in both the figure you can see the X-ray signal is directly converted into amperes, and they are detected. So, first of all we will discuss the direct conversion. An X-ray photoconductor such as amorphous selenium plate that is utilized to directly convert the X-ray photon into electrical charge. Selenium drum based systems are used. Here rotating selenium drum with a positive electric surface, so the charge pattern is proportional to incident X-ray charge recorded during rotation of analog to digital converter. And this is this electrical signal is converted into detected by using TFT, thin film transistor array, which is divided into detector element and arranged into a rows and columns matrix. Electronic component includes TFT, a charge collector, electrodes, capacitor store. TFT electrical switch, it has 3 connections: gate transistor, on and off switch, then source attached to the storage capacitor, and drain attached to the drain lines. So, how does the TFT work? As you can see here in this figure, during exposure TFT is switched off, charge is accumulated and stored. After exposure termination, TFT array activation occurs, leading to turning on the gate lines, and the accumulated charge in the capacitor flows through the transistor to drain line using multiplexers as subsequently to connected charge amplifier voltage conversion, and digitization takes place. Voltage herein converted back into the grayscale value at the display stage. So, here amorphous selenium plate, which is directly converting X-rays into electrical charges, and these electrical charges in turn are used to charge a capacitor in the TFT, and this capacitor is, you can see, is drained out by using the drain circuit to read out, and these electrical pulses are converted back into grayscale image to construct the digital image, which is in the form of rows and columns. Direct digital detector technology has been still not very widely used. So, most of the digital radiography is nowadays carried out by using indirect digital detectors. As you can see here, in case of indirect digital detector, the name itself implies that first of all the direct detector converts the X-ray signal into light signal, and then the light signal are converted back into electrical signal. Here again we use TFT, either TFT or CCDs, mostly TFTs. So, that is where the capacitor acts as a storage of charges. So, capacitor starts to store the charges, and the charges are read out by using the drain circuit, as I told you earlier. So, here this type of indirect digital detectors are, as I told you, mostly it is very popular nowadays, and most of the radiology department uses indirect digital detectors. So, as I told you, indirect conversion of X-rays to electrical signal. Here first of all X-rays are converted into light, then light is converted into electrical signal, So, it is a two-step process. The electrical signal are recorded by TFT, amorphous silicon photodiode circuitries, and scintillation at the top layer of the TFT is sandwiched. The principle is shown, principle of indirect digital detector is shown in this figure. The phosphor material is cesium iodide at gallium oxysulfide, amorphous gallium oxysulfide. So, when X-ray is hit with these detectors, structured phosphor using cesium iodide. So, cesium iodide, when X-ray incident on cesium iodide, it produces light. Then using either charge coupled detectors or TFT, this electrical signal is converted into digital signal, the light signal is converted into electrical signal, and then electrical signal is drawn out by using TFT. So, let us see CCD. The working principle of CCD is shown here in this figure. Here the light sensitive sensors made of crystalline silicon. It consists of an integrated circuit containing an array of linked or coupled capacitors. Its size is very small, about 1 inch in diameter, 1 inch in length. The X-ray converted into light by scintillation, such as thallium doped cesium iodide. Amount of light emitted is recorded by CCD, and this CCD converts the light signal into electrical signal. So, what happens in CCD during exposure? The electrodes in the chip shifts the charge packets. Switching off voltage allows the charge packet to move down. Charge from bottom of the each column spills into the readout row. This process is repeated itself until all the rows of each column is read out. In detector, electronics requires a certain amount of area on individual detector element. The entire area is not photosensitive. The percentage of the area of each detector element that is photosensitive is called fill factor. As you can see here in this is the fill factor, wherein only a small amount is left out for circuitries, and that is not the light sensitive. So, this fill factor is not utilized in converting the electrical signal into converting light signal into electrical signal, as in case of either in a charge coupled detector or in TFT. In both the detectors technology. Now, coming to the advantage of digital radiography. The advantage of digital radiography is that here the digital images are flexible. It allows variety of manipulations such as magnification, compression, edge enhancement, cropping, and inversion is possible. Digital detectors have wide dynamic range. Moreover, the implementation of fully digital packs with the DR is possible, in which images are stored digitally. It can be transmitted in the department or anywhere in the department. Patient dose reduction is possible. Here the doses are comparatively less than conventional X-ray equipments. Digital images do not deteriorate physically or degrade. Image distributed electrically throughout by web technology. But disadvantage of DR is that spatial resolution is less as compared to the film skin radiography. Detectors are fragile, requiring careful handling, high initial cost, and since detector in digital radiographic equipments are fixed, so certain radiographic views cannot be obtained with these technology. We need to have some separate digital detectors for taking, for example, chest X-ray. You need another receptor that should be on the vertical stand, and otherwise, so you need in digital radiography two digital detectors are used. Now coming to the digital image storage and communication. We call it as picture archiving and communication systems, PACS. Digital image includes the storage of patient study images and other relevant information by various methods. The amount of storage depends on imaging modality, workload and storage duration. Storage is a scheme includes online storage, near online storage and offline storage. Type of storage media are electronic, RAM, random access memory. Data can be written, recorded and read out, retrieved to and fro from any place within the memory array. RAM is used to store image and other data on the short term while the images are being recorded, reconstructed, processed and displayed. Then mass storage media, magnetic image. Here image data can be recorded on surfaces that can be magnetized. Recording and reading done on magnetic surface moves close to the device called head, referred to as a hard disk, magnetic disk, magnetic tape. The advantage is that here ability to write, record and read data very rapidly. Data that is no longer needed can be erased to make space available for new data. But the disadvantage is that it has got a limited capacity. Data if lost cannot be retrieved. For example, if data lost, disk crashes. If the image data is confined to a single disk, there is a possibility of data being destroyed in the event of mechanical failure, commonly known as crash. A redundant array of inexpensive disk RAID configuration made up of multiple disks used together to make multiple copies of data to reduce the possibility of loss in case of one disk failure. In case of optical disk, digital store media that records the data in optical form using light compact disk called CD. It's a commonly used optical storage media. Writing or recording is done by laser. A laser produces a relatively intense beam of light that burns the CD. Optical media have a large storage capacity or easily exchangeable. Now coming to the PACS, the picture archiving and communication system. PACS is a hardware and the software that stores and manipulates the digital information in the form of images and text data as shown in the figure. You can see here the data once recorded, it can be processed, and after processing the data it can be sent locally. The image can be transmitted to individual in the department, outside the department, outside the world through Ethernet. So that is the advantage of PACS. PACS are an integral part of, especially for the radiology department. We usually in the radiology department, it is the mini PACS. Now advantage of PACS. The advantage of PACS is that they include increased efficiency of acquisition, viewing and recording of images, efficiency in data management including fewer lost films, cost saving, space saving, environmental benefits, increased efficiency of retrieval of historic image. Now coming to the component and architecture of PACS, it is defined as the property of a PACS as a system that typically acquire, store, transmit, display and process digital image. basic component can be separated into acquisition for acquiring and pre-processing of images, an image acquisition component is needed. Then we need a server. An archiving server is composed of a database server or image manager, short term and long term storage, and a computer that controls the PACS workflow. Third is the display. Finally, to display the digital image, a viewing component is required as a workstation, and other component of PACS or teleradiology, which is defined as the ability to acquire a diagnostic image at one location and review it at a remote location. The database server is the main component of PACS. Server holds a database of all patient examination information. This database includes details of patient demographic and the examination, the patient. It is also used to perform scheduled tasks required for a system maintenance such as backup. Last part is radiology information system, like RES, known as RIS. In the modern digital radiology, Department of Radiology system RIS forms the backbone which controls almost all aspects of radiology workflow. The radiology RIS system drives the workflow and transfer of information across the department. It deals with non-image text based computed functions such as scheduling of an appointment, generation of the bills and the reports. Then DICOM is a set of standard to facilitate the transfer of medical images and related information. DICOM includes the standard for transfer using computer network of images and related information from individual patient studies between devices such as imaging device, the storage devices. It also specifies the standard formats for information objects such as patient images and studies. It also provides grayscale standard display function and presentation status and for consistency and presentation of display and printed image. Now, image compression. This is a method used to compress the images as shown in this figure, because radiology department have a massive amount of data. So, there are challenges for storage and transfer of images. It reduces the time required for transfer of images and increasing the number of images that can be stored, the storage media. So, compression is very important. Image compression and decompression is done. Storage is calculated as the product of number of images and the size in the bytes of an image. Two categories of compression. One is the reversible bit preserving, also known as lossless compression. Image is identical to original. It provides redundancy in date. Irreversible data compression is also known as lossy and non-recoverable information, because the information is lost and so that uncompressing image will no longer exactly match the original image. It permits the higher compression ratios as shown this compression system in this figure, as you can see here. So, with this I summarize the digital radiography as it is. The digital radiography is digital image, presentation of digital image. This is entirely different from the conventional film scan images. Here the images are displayed in the form of rows and columns known as matrix. Computed radiography uses photostem level phosphor technology, photostem level phosphor plates, which are as a image receptor which is loaded into the cassette. behaves much like a cassette to produce latent image with conversion of X-ray signal. PSP, photostimulable phosphor plate, contains barium fluorobromide activated with europium. So when exposure is made, the data is stored in the form of trapped electrons in the F center. When cassette is exposed cassette is read out by using image reader, wherein trapped electrons are excited by the laser beam, and with this light is emitted, which is then converted into electrical pulses, electrical signal, and by using CCD or TFT. In direct digital conversion detectors, which is an integral part of the machine, in case of indirect digital detector, it consists of a scintillator, which usually is made up of structured cesium iodide or gadolinium oxysulfide. When upon exposure emit lights. Light is converted into electrical signal using TFT very often, or maybe CCD, charge coupled detector. Direct digital detector consists of amorphous selenium, which directly converts X-ray signal into electrical signal, and these electrical signal are then used to generate the image by using thin film transistor. PAX system is used to send the radiological images through networking within the department and across the department. With this, thank you very much for your patience hearing.